Okay. You guys need more time or? Okay. Anyone needs more time, I'll just move on. So now we're on Google Colab. So click here to create a new notebook. It's the blue like the blue words and it says new notebook. And once we're on this new notebook, I'll just rename it Handwritten. We don't actually have to do that part. I'll just do it for my own organization. And make sure to go click on runtime and then click on change runtime type. And then here it says hardware accelerator none. Click on GPU. And then let me know once you hit this step. So one more time, once you're on Google Colab, click New Notebook, and then click Runtime, and then click Change Runtime Type. And then instead of None, click GPU. And then once you're done, let me know in the chat. Done. While I'm waiting for more people, I'll just give like a brief explanation for why we're doing this. So it's like one of the reasons why people use Google Colab is because you can do this. You can use a GPU. And so a GPU is a graphics processing unit. And the reason why that's helpful here is because the way that GPUs are built, they kind of go for like more cores instead of like more powerful cores, which is what CPUs are going for. But basically that just means that our code will run faster. And so Google Colab lets us use Google's GPUs. So yeah, that's why we're using Google Colab. So once you've selected GPU, which it seems like a lot of people have done now, click on Save. And just to check that all of this is working, let's, in the first cell, type print, and then just type like hello world. And then press the run. And let's just make sure that everything is working. So again, if you see hello world, just type yes in the chat. just type print hello world. Like, I think you guys have probably done this like a million times. Just type print hello world and then run the cell by clicking the play button on the left. Okay, done. While everyone else like catches up, I'll move on to the lecture. So yeah, let's just begin with all the material. And so yeah, we're also going to be using Google Colab to run some of our code, which is why I wanted to set this up in the beginning. So just as a review, as you know, machine learning is really complicated, and so we can rely on pre-written code called packages to make our task easier. And so today we'll be using Scikit-Learn and Matplotlib. So Scikit-Learn is the package that has a bunch of very basic machine learning like functionality. And then Matplotlib has a lot of plotting stuff, right? As you can guess based on like the name. You can plot a lot of graphs, and this just makes it easier to visualize what you're doing. So to get started, let's just install these packages in Google Colab. Yeah, so I'm going to move on to Google Colab. I'm going to hover here below the cell where it says plus code, and then I'm going to add code. And then I'm just going to install the packages by typing pip install matplotlib and pip install scikit-learn. And then I'll hit run. And so now Google Colab is just making sure all of this stuff is installed. These both should be the default already installed by Google Colab, but this is just to make sure that everything is hit. Just to like speed things up, I guess, because we're trying to learn the concepts right now. I'll just paste the code in the general chat. So yeah, you can use that, and we can install Matplotlib and Scikit-Learn. So once you've installed them and you see like an output that looks something like this, can you guys let me know in the chat? We're done. Cool. Yeah, requirement already satisfied. Yeah, that's what we want. So yeah, now that we've installed these packages, we can use these later on to simplify a lot of our processes. And so yeah, as I said before, what we're going to do today is to classify handwritten digits. And so yeah, as we learned yesterday, supervised learning requires a large data set for the computer to learn from and test itself. And so for our purposes today, we'll be using a digits data set of 8 by 8 pixel images of digits. And each of these are labeled in the data set with the correct number they represent. So this is just an example. We're going to see images that are like 0, and it's going to say 0. 1 is going to be labeled with 1. 2, it's going to be labeled with 2. 3 is going to be labeled with 3. This might seem like really stupid to you guys right now, but remember, all the computer has with these images are just like pixel values, right? It just has a bunch of zeros and ones. And so it's actually a kind of a complicated task for the computer to recognize these digits, like just based on the zeros and ones. And so like that's kind of our goal today. So yeah, to load our data set, we'll go back to Google Colab. We'll create a new cell by clicking plus code again. And then we're going to type digits equals scikit-learn datasets load digits. Oh, actually, before I do that, sorry, I forgot. We should import our libraries first. So we should import pyplot from matplotlib. So that's import matplotlib.pyplot as plt. We should also import sklearn, which is scikit-learn. And then from scikit-learn, we should also import from sklearn, import datasets, svm, and metrics. And then from the module called model selection in scikit-learn, we should import train test split. So this is actually, I'm not going to make you guys type this. Again, I'll send the code in the chat. So to follow along, just copy and paste the code in the chat. So yeah, first let's import our packages by typing those lines. And so this is just going to make it easier for us to refer to those packages by using like these keywords. Next, yeah, so I'll actually import my dataset. So I'll type digits equals sklearn.datasets.load digits. And so type this and then press run. And when you see the checkbox, let me know in the chat. I'll copy the code in the chat again, just to make things easier. And yeah, can you guys just copy those lines in the general chat and then run that cell and then let me know when you're done. While we're waiting, you don't need to follow. Actually, please don't follow along. This is just to show you guys. But while I'm waiting for more people to copy and paste and then run that code, I'll show you what our data set looks like. So again, you don't need to do this, but I'll just show you anyways. So if I set our matplotlib style to gray, and I'm just going to go through the first examples in our data set, and I'll just plot each image, and then I'll just title it with an F string. That just tells us the actual correct label. And then I'll show. So again, you don't need to do this. Just to, like for you guys to see, this is what our data set contains. And so in our data set, we have images, like you saw before, and each image is like a number of like bits basically. And then we're gonna have labels. So this is labeled 0, this is labeled 1, this is labeled 2, and this is labeled 3 and 4. Yeah, don't do this, just again for your reference. Okay, cool. So for what you guys need to do, just make sure you have both of these cells copied and ran. And so that just means we have our data set loaded, and then we can access our data set using the variable digits. Okay. Hopefully, actually, I'll wait for more people to finish. So just let me know once you guys have run through this cell. Type in the chat for me, just like Winston. sorry about all of this code. I think like once you do this a few times, this is going to be very easy for you. I think in the beginning, the best thing to do is just copy and paste and get like a general idea of how everything is working. And then later on, you can go back and then see what each statement does. But for now, I'm just hoping to go for like a broad overview.
Juyeon, are you recording this session?
Yeah, I think it's being recorded.
Okay, yeah, because we have some students that are late and we have to.
Okay, cool. I'll assume that most people are finishing up with this. So yeah, I'll move on to the next step because it looks like a few people said they're done. So yeah. So we loaded this data set. And so right now we just have a bunch of images like you saw with like the handwritten digits, right? And so we want to train our model with this information. But before we train our model, we have to prepare our data set a little. So we just have to do two things for now. We just need to flatten the data. So right now we have an image, right? So it's an 8x8 image, I think, of the handwritten digit. So machine learning models actually only take in vectors usually. I think once you move on to like convolutional neural networks, you'll learn about like 2D arrays and such. But for now, you can just think of them as taking in one-dimensional arrays or vectors. And so we need to turn our image into a one-dimensional array of pixel values to feed into our model. So that's the first step. And then our second step is to split the data. So as you saw yesterday, when we were messing around with the images in Google's Teachable Machine, I had two folders every time. I had a training folder and I had a testing folder. And the reason why is that if we evaluate how our model is doing using our using our training folder, our result is biased, right? Because we're constantly moving and like evolving our model based on the training set. So like even if we have optimally like done very well in our training set, that doesn't mean we can generalize, right? As you saw yesterday, if we tried images of cats that we did not train into the model, then the model did really poorly. And so that's why we have the testing set, just to give us an idea of how the model would do in real life conditions. So like that. Yeah, that's why we need to split the data set. So to do that, we can just head back to Google Colab. Again, click plus code to create a new cell. And yeah, so first we'll flatten the images. And so to flatten them, we'll do, we'll first get the number. Yeah, we can do that. Let's first get the number of samples. Sorry. I'll actually copy this code into the Discord first, so you guys can get a head start on that. But first we'll flatten our images by doing n samples equals the length of the digits images. This is just a number. This is just a number of samples. Sorry, of information we have, and then our actual data we're gonna get by reshaping the images we have, so that they're unsampled by 1. And so this is the 1 part. This is the flattening part because we're making it one-dimensional. And so yeah, we have our data. and then so we can just split the data into training and testing subsets. So for now, I'll just use a 70% training set and a 30% testing set, which is kind of what you normally use in, to begin with. And so I'll just split it, and I'll stick in my digits.target test size. Again, after the lesson, if you guys have time, it'd be very educational to go back and learn all of these commands. But for now, I'm just giving a broad overview. So yeah, I'm gonna run this cell, and let's see, I have a typo somewhere. Oh, I meant -1. Yeah. So I'm gonna run this cell, and then we're gonna be done. For you guys, please run the set the code I have in the Discord channel. And then when you run that cell, you should see something like this. So your output should look something like this. Yeah, so once it's already done. But when you run that code, your output should look something like this. So because I have some additional print statements there to tell you how many images are in the data set, and then what our split looks like. So yeah, please let me know when you're done and you see this output in your Google Colab. Yeah, so this is all the boring stuff basically. Now that we've handled the data, we're gonna be able to train our model. But this is still pretty important, so yeah, just make sure to run this, and then let me know in the chat when you see the output. Again, I have copied the code in the chat, so you guys just need to copy and paste that into your Google Colab. Says it's done, so I'm not sure if that means everyone else is done. Okay. If you've fallen behind, I'm gonna have all of this code one more time copied so you can look at it after the lesson. But yeah, I'll move on. So we've prepared the data set. Now it's time for classification. So this is the training part that we were doing with Teachable Machine yesterday. So yeah, we'll train a classifier to learn from the data and see if it can classify handwritten digits. The model we'll be using is called a support vector machine. It's a very classical model from 1992. And later on, when you guys take college classes or something, you'll see exactly how this works. But yeah, we can use Scikit-Learn to actually abstract a lot of this away. Anyways, sorry. So yeah, we can use Scikit-Learn to access this classifier. And so yeah, we'll create a new code cell like this. And then because it's a classifier, I'm just gonna call it CLF, just short for classifier. And then we're gonna type svm.svc, and then gamma equals 0.001. As you can see, a model is actually quite complicated, and there's many parameters you can feed into it. Gamma is one of them. Again, I won't go over like what gamma does, but just think of it as like epochs or batch size. It's one of those things that you can adjust to change how well a model does. So we'll initialize the model like that, and then we'll train it. So to train it, do clf.fit, and then we can just pass in our training set like this. Again, here's the code in the general chat. And then so, yeah, let me know when you're done. And it actually is, yeah. So we're just initializing our model. We're passing in parameters like we did with Google's Teachable Machine. And then we're training it. So this one line actually trains everything. And you'll notice that it's really fast, and it's really fast because Google Colab has really powerful GPUs. Yeah, I'll move on for now. And so yeah, we've successfully trained our first machine learning model with Python. So congratulations, everyone. We can now predict the value of data, so of any handwritten digits. And so just to test this out, we'll be using our test data set to see how we did. So yeah, we can access our test data set like you see here with xtest. Yeah, with xtest. So we'll just check our data set. This. And so this will just run our classifier on our test set to see kind of how we did. And then additionally, just to visualize some sample outputs, I'm going to run the same code that we just ran above to visualize some examples from our test set. Again, I'll copy and paste this in the chat. But this is just going to unflatten our image. So make it back into an 8x8 image, and then we're going to plot it. And then we're going to title it with the predicted label. And then finally, we're just going to show the plot. So you should see a bunch of plots afterwards. And yeah, you will see a bunch of images. And so for the first image, it looks like a 4, and we predicted 4, so that's good. Again, we predicted 0, and it says 0, so that's good. 5 looks like a 5, so that's good. 3 looks like a 3. 6 looks like a 6. So overall, it looks like our classifier did pretty well. Okay, so Justine is facing a challenge here. Could you let me know what type of challenge are you facing? So in order to see that output, you have to run this code. So yeah, you should just run this code, and you should see the output. Winston says it works. Okay. Oh, it does not work. Digits is not defined. Maybe you did not run the previous cell. Because digits, if you look in the cell above, we put digits equals Scikit-Learn. So can you try running the cell by clicking the play button right next to it, like above the one? So like, just try running this cell first, then let me know if that works. So try running this cell first, then try running this. And then could you let me know if that works in the general chat? If it doesn't, I can maybe figure out something else. Okay, name sklearn is not defined. Okay, so that means that you haven't imported your package yet, I think. So, which means that we have to run this code again. So I'm not sure if you copied and pasted this code yet, but here we're just importing all of our packages, and you can see for one of them it says import sklearn. So try running this code first. Okay, while he's doing that, show you guys like how our model did. Again, this is not something you need to do, but I just want to show you how powerful a simple machine learning code can be. And so I'm just going to compute our accuracy score by doing round metrics.accuracy score. So again, we're using another package. I'm going to put in our test outputs are predicted. I'm going to multiply those two and that. So this is just going to compute our accuracy score and then round it to the nearest second digit, so hundredths digit. And so yeah, I'm going to print my accuracy score now. And so you can see that just based on this code, we got a 97% accuracy. So that means that of 97% of our testing set, we got correct, which is a really good test score. Yeah, so that was just it for this quick demonstration of machine learning with Python. Does anyone have any questions? It looks like some people's code wasn't working. If you guys are still having trouble, here is the full Google Colab notebook. And so you can access that. Winston got 97.042. Nice. Yeah, so that's a really good score. It's like obviously if you get a 97 on a test, you'll be very happy. It says someone said they can't see the numbers very clearly. Oh, so if you're asking about the visualizations, you'll notice in my code that I have this section. And so this section is the part that you should use to visualize some examples. So stick that right after the cell that says number 9. So the cell that has digits equals sklearn. Yeah, again, I posted the full notebook in the chat, so go over that if you have any questions, I think all of that should work. But otherwise, yeah, so we've tested our first Python machine learning code. In terms of future steps, you'll notice that our code ran really quickly. This is partly because we're using Google's GPUs, but also partly because the images are quite low quality, right? You can see that these are all very, very low quality pictures. And so, yeah, this is just a simple toy example. But using these same principles, we can actually use machine learning to track people in the video, predict the stock market, and more. And so some of these examples we'll actually be going over really soon. So to explore some more complicated models, you should check out Scikit-Learn's documentation. Here's also some sources that you can look at later on if you have any questions. But otherwise, it looks like everyone in the general chat got their code working. So, oh, actually, someone's typing. Too. Okay, nice. So it looks like everyone's code is working. Okay, really cool. Yeah, so that's it for my lesson about handwritten digits.
All right, then I'll go next. Now I have a lesson prepared for us too. Let me go ahead and share my screen. Let's see. All right. And then go ahead and let me know if you guys can see my screen, and then we'll get started right away. See it. All right, great. Well, for my lesson today, I've prepared a lesson on supervised learning. I know we went over it briefly yesterday, but for those of you who forgot what supervised learning was, it's basically a machine learning task that helps map an input to an output based on sample input and output pairs that are already given. And then you'll know more what I mean by that later on. And then as for machine learning, you could kind of think of it as a branch of statistics. And then and then today we're going to be learning about the fundamentals of these statistics. So yeah, over here, you could kind of think of supervised learning as a cause and effect, otherwise known as an independent and dependent variable. I know some of you probably have heard of those terms at school, but the cause is basically the independent a variable, and the effect is the dependent variable. And over here, if we go ahead and look at the next slide, you could see that today's example will be predicting a lemonade sale. So over here, we have the cause, which is the independent variable, and it's represented as the temperature. So we have temperatures for these specific dates, 30, 24, 20, and 40. And I'm assuming this is Celsius, but that doesn't really matter. And then over here, we have the effect, which is the sales of the lemonade. So how many lemonades you're able to sell in that day. And as you can see, this is a dependent variable because it's dependent on the temperature. And then in this specific case, you can see that the sales are generally double the temperature, or temperature times 2. And this is the whole idea of supervised learning, because over here, this would be our unknown data that we're trying to find. So let's just say the 80 was missing and we don't know what the number is. But through machine learning algorithms, we know that in previous dates, the temperature and sales given had a correlation between them. And the correlation is that the temperature or the sales is always temperature times 2. So the machine or the computer, knowing that there is this type of correlation between temperature and sales, you're able to come up with a model to predict the sales for June 18, 2022, when the temperature is 40 degrees. So that's basically what supervised learning is. And if we go over here, yeah, so this is what I was talking about before. We have the dependent variable, which is the cause and the temperature in this specific scenario, as well as the effect, which is the independent variable, and the sales, the amount of lemonade sold in a day. Um, oh wait, I think this is switched. Sorry, I think this is supposed to be dependent and this is supposed to be independent, because the temperature is independent from the sales. But yeah, so these two are switched. But basically, after getting these data, the temperature and the sales, you are going to train the computer to figure out an algorithm and to figure out a solution to find the number of sales given any amount of temperature, any number of temperature. And then you're going to create a model through that. And we are actually going to be creating our own model later on. But this model helps us to create a formula to predict future sales. And obviously over here, so for example, if the temperature we have, I can't, can I annotate here? I don't think I can. But oh, can I? Mhm.
Can you start from first slide again?
Oh, which one? This one?
Yeah, they weren't able to hear. And so, yeah, could you start from the beginning?
Oh, sorry, I did not see that. Okay, then from the beginning. Okay. So hello everyone, and today we're going to be going over supervised learning. I know some of you guys, or can you guys hear me now? Just double checking before I start teaching again. Yes. Okay, great. Well, here today we have supervised learning, and for those of you guys who forgot from yesterday's lesson, supervised learning is basically a machine learning task that helps map an input to an output based on example input-output pairs. That might sound a bit confusing, but you'll have a gist of what it really is later on. And for starters, like machine learning, it's a branch of statistics, dependent variable. So if we go ahead and look at this model that's given, or this data, these sets of data. So today we're going to be looking at lemonade sales as an example of supervised learning and predicting these lemonade sales. So if we go ahead and look at this column right here, it's the temperature column. And in this case, the temperature will be the cause, otherwise known as the independent variable. And then over here, we have the sales, which is the effect based on the cause, and it'll be our dependent variable because the sales is dependent on the temperature that's given. So as you guys can tell, you can notice that the sales is double the temperature, and that's where this comes from. In this specific case, we know that the temperature will be generally times 2, the sales is generally going to be times 2 the temperature. But obviously in real life and predicting real life data and outcomes, it's way more complicated than just times 2. Today, we're just using times 2 as kind of an example to understand the concept behind supervised learning. So like I mentioned in the first slide, we are trying to find unknown data based on previous data that's already given. So for example, pretend that this number 80 is not here, and we don't know what the sales is going to be on June 18th of 2022. But what we do know is previous sales and previous temperatures and previous sales for those temperatures. The temperature model x times 2 is created with the computer. Yeah, yes, that's correct. The temperature model times 2 is created by the computer automatically. But just know that in real life, it's going to be way more complicated than just times 2. But yes, you are correct. Okay, so going back to what I was talking about, because this is unknown data, we don't know what it is. But what the computer does know is previous data that have been collected. And the computer runs through many test cases and trains itself. And then it realizes at some point that the temperature times 2 will always just equal the sale. So that way, using the input and the output from previous data, we were able to find the output based on the inputs given, and we were able to find the unknown data that way. So over here, oh, and then just know that this is the independent variable and this is the dependent variable. It was flipped because the sales is always dependent on the temperature. But basically, this whole idea of supervised learning and machine learning in general is that we have the set of data right here that's given, and we're going to train our computer to come up with an algorithm. And we have this model, and after training, after the computer trains itself a lot, it'll come up with a model. And in this case, the model that they came up with is temperature times 2. And the model helps us to create a formula to find the unknown data in the future. And obviously, like I said, the model itself has more complex algorithms than just temperature times 2. But it'll get as close to temperature times 2 as possible. So later on, you could see when we actually program, the output won't always be temperature times 2. Like for example, if we input 40, then the output might be something like 79.5 or even like 78, because it won't be exactly temperature times 2. I guess kind of similar to this concept, it's if you did calculus and you know limits, you know that if you're approaching a number, that you'll never actually get to that exact number, but you'll try to get as close to it as possible. That's kind of the same situation here, that we will try to get as close to temperature times 2 as possible, but it won't exactly be temperature times 2, if that makes sense. Okay. Yeah, so this is basically what I said. The model, or going back to this, and then, for example, if you have a temperature of 50, then through this training and through this model, the computer is able to output 100 here, or close to 100, maybe 99, 101, 98, but as close to 100 as possible. And this is basically what I've been repeating the past couple of slides. You have an independent variable. Once again, it's the independent. And this, in this case, this is the temperature. 15 will be the temperature. You put it into the model that the computer has trained itself and created on its own using algorithms. And you ultimately get the effect, or the dependent variable, which is the temperature. And then it'll be 30, because 15 times 2 is 30. So I'm pretty sure yesterday we went over classification, and lemonade sales goes under the category of regression. So basically the whole idea of regression is that there's a formula, and if you put one number in, you get another number. And like I said, today we'll be going over lemonade sales, which is regression. And then over here, this is really important for the next couple of lessons that we do machine learning. This model and this picture is going to be really important. So you want to soak up the steps into your brain and really memorize the steps and really understand how it works. So there are typically 4 steps when it comes to creating this supervised learning or creating this machine learning algorithm, the first step is to prepare the data. The independent and the dependent variable, we want to have the data is prepared. And then we want the data that's relevant to the problem. And in this case, the data that's relevant to the problem will be temperature and sales, because we do remember here we have date, but this is not relevant to the problem, so we won't be needing the date. So that's just heads up. And then after we have the data all prepared, we want to be able to create a model. So this is creating a model is kind of like the most complex topic, and it's really complex. But in our class, we're not going to focus on the little details, but rather like on how to like what every command does, but rather we're going to focus on the concept of creating a model. So I'm going to show you the code later, and it's going to be confusing. And you're going to ask like what this code even means, but that won't be our focus. And the whole idea for today's class will be just the concept of what a model does. And the model is used to predict the outcome. And then once the computer is able to create a model, you want to be able to train the model. So the model is randomly generated off like specific factors. And most of the time, it'll be inaccurate at first. So the idea is, like, for example, kind of the way you could think about it is you're teaching a little kid how to, you're teaching a little kid how to do something. So obviously, they're not going to be good at it first, and they're going to make a lot of mistakes. And same with the computer, they're going to make a lot of mistakes. The computer has like a trial and error system where it's going to constantly try and constantly make the model better until the outcome is similar to the ideal outcome and until the outcome becomes as accurate as possible. So that's number 3, where we train the model to become accurate and efficient. And then after we have the perfect model for the solution and for the problem, we have step number 4, which is using the model to predict the outcome. And we could predict the value. All right, so today we're actually going to go ahead and try creating this model. So if everyone can just open Collab. For me, how I open it is I just go to Google Drive, the new, more, and then it says Google Collaboratory. I don't know how you guys open it, but I know you guys all have Google Collab downloaded. So go ahead and open that up. And then you're going to title it Lemonade. I already have one titled Lemonade. So I'll just do Lemonade 1. And then I'll give you guys a couple minutes to pull it up and type it or name the thing. Fine. All right. Well, before we start, I think it's important to know a couple of what do you call it? Shortcuts. If you hover over that plus code, you see where it says Control M plus MB, Control plus MB. So you could do that on your keyboard type in Control MB, and then you'll create a new line. So that's going to be really helpful instead of just clicking plus code every time. And then another thing that you should probably know is Control F9. It's to run all. But other than that, I think you guys will be good. Then let's go ahead and get started. Oh, and I forgot to tell you guys, but basically creating an actual model is very complicated, but thanks to TensorFlow and Pandas, we already have software libraries that we could just use. That makes creating models super easy with just simple commands. So we might not necessarily understand what each command does, but like I said, we will understand the concept of how to use a model. So we are going to use TensorFlow and Pandas. So then let me go ahead and actually import TensorFlow. And then let me just zoom in so it's easier for you guys to see. So import TensorFlow as TF, and then import Pandas as PD. And the number 1, this is going to be the step 1 of this picture. Prepare the data. Or otherwise, or just gather data for short. And then I'm going to send you guys a link in chat. We're going to be using that link, and that's containing all of our data for today, or for the lemonade example. So just have that prepared. And then we're going to create a data path. And then that's where the link actually comes into play. So we're going to copy and paste the link and just put it over here. And then as you can see, it has the temperature, the sales, 20, 40, all of the data. And just an FYI, CSV basically means comma separated variables, because all of these are separated by commas. Right here. Then enter. Then we want to create a variable called lemonade. pd.read the comma separated variables. Data path. So that's where our that's where data is being stored. And then you could go ahead and actually print out lemonade. Does this print it out? Oh, okay, wait. It's going to create an error because I forgot to run this first code. Yeah. So remember, when you're using Google Collab, it's important to run each step first before. So I guess the best thing to do is just do run all. That way it just runs through all of them. Because if you don't run this and run this first, then the import TensorFlow and import Pandas won't happen. And that's how the error normally occurs. And that's how it happened for me right now. But if you just have Lemonade over here, it prints out using these commands. We have the temperature on the top with the sales, as well as the specified data for each variable, as well as the 5 test cases, or it's 6. Yeah. All right. So we have step 2, which is to create a model. But before we create a model, we have step 2A, which is to separate the dependent, and dependent variables. Because we want to have these, right now they're all in Lemonade, but we want to be able to separate the independent on its own as well as the dependent on its own. The way to do that is create a variable called independent. Make sure you get the spelling right too. Equals Lemonade. We're bringing it from Lemonade. And then temperature. And I spell that right. Oh. And then the dependent is a sales. And then if we can make sure that we have these, we could do independent dot shape, comma, dependent dot shape. And then as you can see, we have 6 columns, or 6 rows, sorry, and then 1 column, 6 rows, 1 column, which perfectly matches the output. So we have 6 variables here for temperature, 6 variables for sales. I'm just gonna pause right here for a second for you guys to catch up. You're getting an error. It says PD not defined, so you probably didn't you probably didn't run this. You need to run this first so that you could import the pandas and the TensorFlow, and then you have to run this to gather the data. And another thing that's helpful is to just run all. Yep, no problem. And then let me know when I can move on. And then we will next create the actual model. Done. All right. And make sure you have it's print out the same things as me. So you have this table as well as the 6161. I'll wait for other people to finish too. So if another person says done, and then I'll move on. Yes, in the meantime, I could kind of explain what we did so far. The first important thing is to import all the software libraries that we're going to be using. In this problem, we're going to be using TensorFlow and Pandas. TensorFlow to create the model. And then we have this thing called data path, which has the link to our this page right here that contains all of our data. We're going to assign that to Lemonade, a variable called Lemonade. And if we just print out Lemonade, it shows the table. Oh, and one cool thing, just for future reference, because I know over here, the data that we're working with, we only have 6 data. But later on, we're going to be working with hundreds and thousands of data. So if you don't want to print all of them out sometimes, what you could do is lemonade.head, and it just prints out the first 5. So you see how it only prints out 5 variables. So if we had, let's say, like 100 variables, we don't want to print, or like 10,000 variables. We don't need to print out all of them to make sure that it's working correctly. We just need to print out maybe the first 5. So then you could use the .head command. But for this specific lemonade stand that we were doing, the projects, we don't need the .head because we only have 6 variable or 6 data temperatures and sales to work with. Okay, then I think I can move on. So Control MBAN for a new line. And then now we have create a model. And then do you see these basically these comments that I have? Try to memorize it. It's really to memorize. So number 1, gather data. Number 2, create a model. Number 3, train the model. And then number 4, use the model. It's pretty straightforward. And then 2A, if you want, you can, I guess, memorize this too, but you don't need it. Just know that you do need to separate the variables though. Okay. Let me make sure that there's no other comments or okay. Nice, we can move on. Then we are going to create an x and y variable. So x equals, and this is where I mentioned earlier how the coding and the actual code might be a little bit confusing, but you don't need to understand what it does. You just need to understand the idea and concept of the model. And if you want, if you're curious on what each line actually does, then you could go ahead and search it up on your own and on your own time and learn. But basically, it's tf.keras.layers.input shape equals 1. And then y is equals to tf.keras.layers.dense 1, because we have, yeah, and then x. And then we're now going to create the model. Model equals tf.keras.models.model x, y, and then model.compile loss equals MSC. So like I said, you probably have no idea what this means. And to be honest, I don't really know what it means either, line by line exactly. But I know that what this is doing is this is creating a model, the times 2. Where did it go? The temperature times 2. This is what's being created right now. And that's all you need to know for today's lesson. Obviously, if you're curious, go ahead and just search it up on Google on your own. But this is all you need to know, that these commands exist and these commands help to create a model. And then if you guys could type done if you're done, then make sure you go ahead and run this too. Or you could just do run all at the end. Either is fine. And number 3, I'll just type out the comment for now. And number 3 is going to be train the model, parentheses fit. Because we want to constantly run the model until basically it gives an accurate result. So once again, if you guys are done with number 2, create a model, type in the chat that you're done. Then we could go ahead and move on. What's the problem? Oh, the input is capital, by the way. Oh, what did I do? The input here, the I is capital. It's lowercase in the screenshot. For Winston. Not lowercase I, but capital I. Right here. All right, then are we good to move on? I think we can. All right, and then this is where I mentioned before, just like how a little kid needs a lot of time to practice, but it does run. Okay, okay, that's good. Just like I mentioned, how when you're a kid, or even now, when you're learning something new, you need a lot of time to practice it. And that's the same with this model, and same with the computer. They need time to practice to make the model as accurate as possible. So we will have 2 lines of code, or here. So model.fit is how you are going to train the model. That's why I have fit in parentheses. Okay, make sure you spell it right, because then it's gonna create an error. Independent. And then we have something called epochs. Oh, I don't know if I'm pronouncing that right, but basically what it does, it's epochs is a hyperparameter, and it defines the number of times that the learning algorithm will work through the entire training data set. So it's kind of like I guess you could kind of think of it as a for loop, but it's basically the amount of times that it's going to train. And obviously, we want it to train multiple times, and because our computers are fast, let's actually just start out with 1,000. Or actually, let me just do 100, and let me show you. But the only problem is we don't want to, like, there's so much that's being outputted. We don't need to see all of this. We just want to, let's say, maybe we just want to see 10 to make sure it's actually running, but we don't need to we don't need it to print out all of this. That's why we have something called verbose to hide it. That way, if you run it, it doesn't print out all of those lines, 100 lines, because later on this number is not going to be 100. It could be even like 1,000, 10,000. So we don't want to print all of that. But instead, what we can do is independent, the dependent, and then instead just have like 10 over here. So that way it runs through 1,000 times. But then it also runs through 10 more times. And then it actually prints out those 10 times. So it's pretty cool. It might take, oh, I spelled it wrong again. You see how it only prints out 10 times? And then this loss here, it's basically how accurate it is. And right now it's super high. We want it to be as lowest as possible. So we could run it even like 10,000 might take a long time. So maybe like 5,000 times. So the whole idea of it is that the more you run it, the more accurate it gets. And you see how now it just shrinked drastically and it's less than 1. So that's how accurate it is. So the more times you run it, the more times. So how many times did we click on this? I think we clicked on it like 3 or 4 times. So basically the model has been trained like 10,000 times already, or 15,000, or no, I can't math. Yeah, basically 15,000 ish. Because before it was at 1,100. But the whole idea is that it trained a lot and it went through a lot of trials and I guess you could say error because the loss was super high. But now after training it like a lot of times, the loss is super low, which means that it's more accurate. And that's what we want. So we want to train it as much as we can to make it more accurate. That's the whole idea and concept for today. So let me know if I can move on. $2,000 more. Okay. I guess let's just try to make it the number as small as possible. So it's the most accurate when we actually print out the number. If the loss is about 800. If the loss is about 800, that means you just need to keep running it until it's super low. We want it to be really low, the number. Oh, like for me, it has e to the -4, which means it's this decimal 4 times to the left. So it's a super low decimal. And this is generally what we want. Make this loss super low. So if it's 800, I want you guys to run it a couple more times to make this number super low. And then now we can go over to the model. This is the last step. And this is how we're going to use the model to predict the data. This is also just printing out model.predict. And then let's just put 15 here to see what we get. And then look, notice how it's 30 or close to 30 because the model, like I mentioned, it should be somewhere near ×2, but it's not necessarily going to be exactly 2. It's because the algorithm that the computer uses, it's more complicated than just temperature ×2. There's so many other factors that comes into play. So that's why the number here is not going to be exactly 30. But if you input 15, and because we trained it multiple times, so the loss is super small, which means it's going to be as accurate as possible. Let me actually try something. Let me run this one more time. And then let me see. Yeah, you see how this changed? It got even more accurate. Well, now we have a model to predict the outcomes for the unknown variables. And then we could also just do print model.predict independent. I can't spell. In the, oh, here, I can just press enter. And let's see what that gives us. 40, 42, 44, 46. And I am pretty sure this, yeah, this is this variable here. So let me see if I could print just lemonade here. Can I do that? Yeah, okay. Or let me just print the dependent. Dependent. Sales, okay. Notice how, and then let me just comment this. 40, 40, 42, 42, 44, 44, 46, 46, 48, 48, 50, 50. But there's also decimal places. It's not exactly times 2. And then we can actually do one more command, print, or model.get weights. And then this is, I think